New Zealand has lots of forests. In fact, 38% of the landmass is covered in forest. Approximately 80% of that is natural forest, whereas just under 20% is managed plantation. These plantations not only provide habitats for creatures, greenhouse gas capture and billions of dollars to the economy, but managed forests also prevent natural forests being chopped down for the multiple uses of wood. Regrettably, managed forests have inherent risks for humans, with over 150 injuries a year resulting in more than a week off work, and the rate of fatality is sadly much higher than agriculture or manufacturing. Robots are usually kept within cages in factories to save humans from such dull, monotonous and dangerous jobs. But robots are starting to break loose. Robots are starting to enter day-to-day life next to humans. This raises many interesting questions, such as how do robots work safely with humans? How do they navigate in unstructured domains? And how can they sense the world around them? Academics and industry are interested in such questions, whether robots are to be employed indoors in factories, working collaboratively with humans, or autonomously in outdoor settings. It happens that such outdoor forestry settings are exceptionally challenging, so a great environment to develop the technology for advanced robotics. So if you go down to the woods today, you might just see a robot, but the robot will also see you, plan a safe path around you, and get on with the valuable tasks such as monitoring the continued health of the forest.
SIFTI's role is to increase New Zealand's capacity to use physical sciences and engineering for economic growth. The balance between new science and impact for industries is a really tricky thing, so you need both. And it's been pretty effective here because the researchers have continued to talk and engage with the industry as they went along. And the demo we had today was an example of that. So engaging with industry which directs the fundamental research that happens.
The unique value proposition of the Spearhead was, of course, bringing all these researchers together, finding a way for us to work, bringing all our complementary skills together. And it was actually easier than we thought, getting a variety of researchers around the country together, working on a unique problem and try to solve something that ultimately is extremely difficult to do. But the challenge made it possible for us, and thanks for the support of the National Science Challenge.
We present the Robotics Spearhead, a 5-year project initiated and funded by New Zealand's National Science Challenge on Science for Technological Innovations. We created new knowledge and developed new tools for robots in challenging outdoor conditions, like a forest. This journey was an interdisciplinary effort of scientists and engineers in computer technology, computer vision, robotics, artificial intelligence, machine safety, and specialists in robot applications. We work with robot manufacturers and end users, like the Taupo Forest Trust, our host here today.
I was involved right at the very start of the robotics project, especially for today, and I have totally seen the progression right from when they first came to the forest to test their robot right to today, and I can tell you it's been an immense change, and also the progress has been huge. So yeah, very exciting.
In the project, we developed a new understanding and tools for outdoor robotics. Robots can better perceive the environment, learn from previous actions, and run in challenging terrain while operating safely with people. Today we show our success in bringing together some of our key results in a real robotic machine. We call it our demonstrator. This robotic platform can move in the harsh terrain of a forest. Path planning is done semi-automatically by combining digital terrain information with the robot's capabilities.
In this case, it's not just about business of the trees, it's about ensuring the whenua is sustainable at a level that's very meaningful to Māori, because other forestry companies, it's often just about the business. They don't own the whenua and they just need to optimise their profits. But this research needs to be across both. They're both important, and also important is a new element we're bringing in around cultural connections to the whenua and to the forestry business.
Well, we're in a game forestry that's still very manual in a lot of its aspects, and we feel that we need to get more technological across the board, really. It was impressive to see the wide range of researchers there are, and from different institutions that they've put in today. It was the first time we've seen them all working together like that, and to get some understanding of the complexities of the different aspects that they are having to pull together to make a robotic machine, ultimately, is what their immediate task is, and they're really starting to crack it. It was impressive.
So the follow-up project is called Ending with Impact, and that is in fact the main purpose. We want to end what we've developed, the technologies that we've developed in the original project. We now want to produce an impactful outcome that is something that our end users and industry can actually really use. So it's a project where industry is leading the conversation instead of the researchers.
It's highly relevant to how we see people working in the forest, connecting to the nature of our forestry business. We want to be one of the leading edge in terms of the way we work.
Work in the forest and our people's most significant problem. Health and safety comes to probably the forefront, and the other one is also having the available workforce to do the jobs.
So I think that a lot of the fear that may be out there around just the unknowing on what the involvement of robots are going to be. I think that if we can ensure that we're integrating robots into our current performance and productivity, that it complements our current workforce, and mainly to build the trust up that robots are there to enhance our operations and our whānau more than a replacement of our whānau.
Robots working in close proximity to humans safely, and that is one of the main focus of our research in this project.
Under the research strategy, knowledge is one of our main aims. Not only that, but we have some priority research themes. One of them is around technology and innovation and robotics, and what is the future of the forestry business going to look like.